Hey everyone, so this video is a little tutorial on how to find horizontal asymptotes. So all of these asymptotes, vertical asymptotes, horizontal asymptotes, slant asymptotes, they all are important to be able to find when you're going to graph a rational function. So this is just a piece of the puzzle needed to graph a rational function. Horizontal asymptotes, we have a different set of rules, right? We just talked about vertical asymptotes, set the denominator equal to 0, solve, you're done. Horizontal asymptotes are a little bit differently, work a little bit differently. So I'm going to show you 3 different examples first, and then we're going to talk about the procedures that need to be done to find the horizontal asymptotes. So to start here, let's just look at this one. And what I want us to notice is, so this is the blue function g of x right there. We can look at this graph and know the horizontal asymptote. It's the same thought process as the vertical asymptote. So when we look at this, again, an asymptote is a line the graph approaches and never touches. So instead of thinking vertically now, we're thinking horizontally. So we know right away that we've got a horizontal asymptote at, what is that, y equals 1. So we write it as an equation. It's an equation. We need y equals 1. That's our horizontal asymptote. There is some way, there's a rule here, how we can get y equals 1 out of this equation g of x, okay? And what I want us to notice is that when it comes to horizontal asymptotes, we are looking at the degree of the numerator and denominator. So if we've talked about degrees before, that's the highest exponent. So I want you to notice that both the degree of the numerator and denominator here is the same, okay? And somehow we're getting horizontal asymptote of 1. We'll figure that out in a moment. Let's look at our second example here. Now we've got this green function, and again, we can look at this right away and try to find a horizontal asymptote. Notice it doesn't seem like there is one. We can see we've got a vertical asymptote right here. And it might even, if you can kind of piece this together, appear that we've got a slant asymptote, but it doesn't seem like we have a horizontal asymptote. So again, notice if you look here, so I'd say no horizontal asymptote. Notice, look at again the degree. The degree is bigger in the numerator, so I'm going to say numerator degree is bigger than the denominator degree. And that results in no horizontal asymptote. And then let's look at this last example here, guys. We've got this purple function. You can tell we've got a vertical asymptote, but let's look at our horizontal asymptote. It is right here at y equals 0. Let's go over and check out the function and the degree. Notice now the numerator degree is less than the denominator degree. Okay, very interesting. Check that out. And those are our rules here, guys. We are looking at the degrees every time, the degree of the numerator, the degree of the denominator. And there are 3 different cases. Okay, so it says, look at the degree of the expressions in the numerator and denominator. And we're going to write n represents the degree of the numerator, m represents the degree of the denominator. 3 different possibilities. The first one is that the numerator degree is less than the denominator degree. So when it's less than, y equals 0 is the horizontal asymptote. Notice that's what we said in that purple graph. The next possibility is that they could be equal to each other. The numerator degree is equal to the denominator degree. This is when we look at the leading coefficient. So it says then the line y equals a over b is the horizontal asymptote, where a is the leading coefficient of the numerator and b is the leading coefficient of the denominator. And so if we look at this example, I can really show you that a little bit more clearly now. We had said that the horizontal asymptote was y equals 1. Notice if you look at the leading coefficient of the numerator, it's 1, and the leading coefficient of the denominator, it's 1. So that's how we get the horizontal asymptote is 1. And then we have less than, equal to, and now we can talk about greater than. If the numerator degree is greater than the denominator degree, then there will be no horizontal asymptote, which we saw in the one with the slant asymptote right here. Okay, so I've got 3 examples. I believe we can check them out. Lost my page. Here we go. Okay, find the horizontal asymptotes of the functions below. I go through and I say what the numerator degree is. Numerator degree is a 1. Denominator, remember we use m for denominator degree. Denominator degree is 2. So then I go, numerator degree is less than the denominator degree. If we need to refer back to what that means that y equals 0 is the horizontal asymptote. And that's it, guys. We're just comparing the degrees. So notice numerator degree is a 2, denominator degree is a 2. Notice now our degrees are the same. What's that mean is we need to look at the leading coefficients. The leading coefficient is a 3. The leading coefficient of the denominator is a 4. So y equals 3/4 is the horizontal asymptote. So like that would be a horizontal asymptote. If this was 1, this was 2, it would be at 3/4. That would be a horizontal asymptote. And then let's check out C. Numerator degree is 3, denominator degree is 1. So it's bigger in the numerator than the denominator. So there is no horizontal asymptote when that happens. Okay? That's how we find horizontal asymptotes. Send me any questions if you have them. Great job, guys.